This sheet in particular is going to be very beneficial to you. There'll be a lot of stuff here you can look back at to figure out how to do. But the first thing they talk about is how to find intercepts. And intercepts for parabolas are no different than intercepts for lines in the sense that if you want to know an x-intercept, then you should let what be 0? If you want to know an x-intercept, you let y be 0. That doesn't matter if you're talking about a parabola, a reciprocal, any type of function. If you want to know the x-intercept, you simply need to let the y be 0 and then solve for x. And then vice versa for the y-intercept. If you want to know a y-intercept, then just let x be 0. All right? Now, I do have some pictures for you. You guys already know a line. A line typically has one x-intercept and one y-intercept, unless, of course, it's vertical or horizontal, and then it would be missing one of those intercepts. But a parabola can either have 0, 1, or 2 x-intercepts, and here's pictures of each. It can have 0 x-intercepts if it looks like this, right? If it's in this quadrant headed down, it's never going to touch the x-axis. This one, the vertex is on the x-axis, and that point itself is the only x-intercept. So the vertex can be your x-intercept. And then in a case like this, you're going to have 2 x-intercepts. Correct? A parabola always, always, always crosses the y-axis somewhere. Okay? This one's going to cross way down here, so's this one. This one's going to cross way up here. But you will always have one y-intercept when you graph a parabola. Okay? So in this little area here, I go over function notation, which we've talked a little bit about in the previous lesson. Having an f of x is no different than having a y equals. Okay? The only difference is you would only use an f of x. If something is not a function, you would not use an f of x. Okay? But that's not hard because, like, for example, a circle is not a function. So typically you don't see circles written with the y by itself anyway. Okay? But if you can replace y with f of x means the same thing. Function notation for a point, like for example, when you have a line like this, if you plug the number 1 into this point, -5 times 1 plus 3, you get -2, right? Okay, this over here is the exact same thing. It's just function notation for a point. It means take the number 1, put it into function f. So if I go here and put a 1 into function f, that's -5 times 1 plus 3, that's -2. So anytime you see this kind of notation, it just means this. Okay? Does that make sense? It's point notation in function notation. Is everybody okay with that? Okay, let's scroll down a little bit. Okay, so parabolas, they always have a vertex, right? So we already, in the last chapter, went over lines left and right, inside out, upside down. You should know everything there is to know about a line. But when you graph a parabola, you could have it in one of two forms. It can either be in vertex form or it can be in standard form, all right? There are other forms as well, but these are the only two that really matter, standard form and vertex form, all right? So when you're in vertex form, the nice thing about it is it's easy to find the vertex, right? Your vertex is going to be at HK. And so remember that you would keep this number the same because that's what a plus sign in a formula means. Keep it the same. This means it's the opposite. So whatever this is right here, you're going to put the opposite of that over here. Okay, does that make sense? Your axis of symmetry. Anybody know what an axis of symmetry is in a parabola? If that's my parabola, then that's my axis of symmetry. It's a fold line, right? It's a line you can draw down through the parabola that allows you to fold it right on top of itself, and it always goes through the vertex. So the axis of symmetry is a vertical line. How do we write vertical lines? X equals a number. So for an axis of symmetry, you write x equals wherever it crosses through the vertex. It's always going to cross through the vertex at h, because that's the x value of the vertex. So an axis of symmetry is always, always, always x equals wherever it crosses the vertex. Okay? Vertical line. Does that make sense? Okay, so now if we look at standard form, in standard form, that's a format you're very used to seeing. You guys know that anytime you use the quadratic formula, you have to be in that format, right? But if you're in standard form, just remember how with lines, if you're in standard form, you can do a negative a over b to find slope and stuff like that. Well, to find the vertex when you're in standard form, you can do negative b over 2 times a. So the opposite of whatever b is over 2 times whatever a is will give you the x value of the vertex, which is known to us as h, right? So h is equal to the x value of the vertex and is negative b over 2a, okay? Then I plug that value back in, and that helps me find the y value of the vertex, which is also known as k. Okay, this is my h. When I plug h back in, that will give me the k value of the vertex. Is everybody okay with that? We'll do examples. I'm just going through the formulas you need to find those. Okay? Everybody okay with that? All right, so down there, the next section, it says to find points on a function. There will be a lot of times it will ask you, give you a function, say, give me 2 points on this thing. All right, so to find 2 points on a parabola, it's no different than finding 2 points on a line. You got to pick numbers for x and plug them in. So let's see here. So it says pick a number for x and plug it into the function to find y. That will allow you to find a point on a graph, whether it's a line, a parabola, a reciprocal function, whatever it is, that will allow that to, for you to do that. Okay? Okay, so now we're ready to start with the examples. We will refer back to that page as needed. So we're ready for example 1, and there's a few questions over the linear function. In the last chapter, we really did not talk about lines in terms of it being a function, so you'll see the f of x notation there instead of the y. But it's going to ask you for the slope, the y-intercept, a point on the line, and then you have to graph it, all right? Which is just pretty much review from last chapter. How do I take this thing and put it in y equals mx plus b format? All right, distribute that negative, so I'm going to have x minus 13 plus 13 minus 4x. All I've done is distribute this negative to both of these terms, okay? And if you would rather have a y out there instead of an f of x, that's fine, use a y. So the 13's cancel, and I'm left with y equals what? Yeah, negative 3x. If I put my x's together, I get a negative 3x. So if you would like to put a plus 0 on that so that you understand what the y-intercept is, that's fine. What's my slope? Negative 3. And they'll want you to reduce it to as much as you can. Y-intercept, so where does this thing cross the y-axis at? Okay, and I have to be more specific. A y-intercept is a point, so they're going to make you give the answer as a point. So 0, 0. Okay, and then they're going to ask you for another point on the line. So how can I find another point on that line? You can graph it and look at the graph, or you can just pick a number for x and plug it in there, right? If I pick the number 1, then negative 3 times 1 is negative 3, right? So there's another point on that graph. So to graph that, I need to cross at the origin. My slope is down 3 and right 1. Or I could choose to go up and left. My line should be downhill when I get done. Does it look downhill? I believe it does. Okay, so there's our line. Did the point we chose end up on that line? We said 1, negative 3. Sure enough, 1, negative 3 is on that line. Okay? We went up 3, left 1, or down 3 and right 1. One of your directions had to be negative. Does that make sense? Okay, everybody okay with example 1? All right, example 2 is another linear function. It's just a little more difficult to do the algebra on, but not bad. I would want to distribute my 4, right? So if I distribute my 4, I'm going to use a y instead of an h of x. So I'm going to have 4. What do I get if I take 4 times 5 thirds? 20 thirds. Everybody agree with that? It's like 4 over 1 times 5 over 3. Okay, so that's going to be 20 over 3, right? All right, and then I have a plus 5x on the end. What should I do to get rid of that fraction? All right, multiply by 3, and that's another reason to use the y here, is because it might look kind of weird if you have a 3 times an f of x. So if you take everything times 3, you're going to have 3y equals 12 minus 20x plus 15? 15x. Does that look right?
Yes.
Okay, so now I can put the x's together. What's negative 20 plus 15? Negative 20 plus 15 is negative 5x, right? So remember, I'm trying to do a line, so we'll get this in the right format. How about a negative 5/3? And then 12 divided by 3 is 4, so I'll put the plus 4 in the end. Does that make sense to everyone?
Yes.
Okay, so let's graph that thing. I want to cross the y-axis where? Okay, so right there is where I'm going to cross the y-axis, and I have a slope of negative 5/3. So, I mean, I have to go one negative direction. So I'm going to go down 5 and right 3. So if I go down 5 and right 3, I will land right there. All right? And then do it again to get a line all the way across. 1, 2, 3, 4, 5, and over 3 should land me right there. I can also go up 5 and left 3. 1, 2, 3, 4, 5. One of my directions has to be negative. And then you can connect your points to make your graph. Okay? Negative 5/3. Remember, your y-intercept has to be written as a point. So if I write my y-intercept as a point, I got what, 0, 4? Okay, and then I have to give another point, which you can look at your graph to get that point, or you could simply replace x with a number that will cancel with 3. So what's a good number to pick for x if you're going to cancel it with a 3? How about a 3? So if I let x be a 3, that means negative 5/3 times 3 plus 4. So my 3's cancel, and I get negative 5 plus 4, which is negative 1. So then you can look at your graph. Is the point 3, negative 1 on our graph? Is it?
Yes.
Okay. Yep, it is. All right, everybody okay with that? Example 2. All right, I think that's our last linear function, is it? Oh, nope, we got another one. Okay, so another linear function. And I want to get it in the form y equals mx plus b, so I will make that a y. What should I do? Multiply by 3? Right, to get rid of this, so I'll just go ahead and make that a 3y. 12x and minus, and I'm going to keep that parentheses to make sure you understand you have to distribute the negative. Okay? And I don't even know if they'll put a parentheses up there. Hopefully they do, but if they don't, that negative goes with that whole fraction, so you've got to change the sign on the entire numerator. So 3y equals 12x minus 7 minus 3x. Does that make sense? Okay, so now what? Yeah, so what's 12 minus 3? 9x. And then divide everything by a 3, and I get 3x minus 7/3. So this one is not necessarily a fun one to graph. So when you tell the computer to graph this thing, it may just ask you for 2 points. So your slope is 3. What's your y-intercept?
0.
And so let's try and get another point. So what kind of a point do you think we should pick for this? Okay, so if you pick a 1, you've got 3 times 1 minus 7/3. So 3 times 1 is 3. How do I do 3 minus 7/3?
You got a
Common denominator, right? So I have to change 3 to something that has a denominator of 3. So what number divided by 3 gives you 3? 9. 9 divided by 3.
But isn't it just 3 over 1, then you can just multiply that by 3?
Yes, which gives you what?
Oh,
9, right?
I see.
Exactly. So I'm changing the 3 to terms of thirds, so that would be a 9/3, right? 3 is the same thing as 9/3, so I'm going to change that to a 9/3 by common denominator, and 7/3 minus, or 9/3 minus 7/3 is 2/3. So there's a point. Okay? So now I could use the intercept and that point to make my graph if I wanted. So 1 2/3 would be, what, right in here, like that. And my intercept is at negative 7/3, so that's about what, negative 2 1/3? So there's 2 points, and I can make my line based off those 2 points. Okay, so you can see them. That point right there is at negative 2 1/3. That point is at 1 2/3. Okay? And there's your line. Okay, everybody okay with that? All right, ready for example 4? Find a linear function with the given properties. Okay, so they're giving me some properties of a linear function. They're saying, hey, r of negative 2 is equal to 6, and you get a slope of 1/4. Well, do you remember me telling you what this notation means? It's just a point, right? That's the x and that's the y if you write it in point notation instead of function notation. When you write a point in function notation, it looks like that. So it's really the point, negative 2, comma 6. And my slope is negative 1/4. So now I have to write a linear function with those properties. It did not specify whether I needed to end up in standard form or slope-intercept. What form am I going to have to start in? You're probably going to start in point-slope form because you know a point, you know a slope, right? So if I get a point-slope form, I'm going to have y minus 6 equals negative 1/4 times x plus 6. Oh, sorry, I got that one. Plus a 2. Okay, now, they said write a linear function given these properties. Well, I just did. Why can't I just put this as the answer? Because it's going to say they wanted you to write it as a function, which means you need to use function notation. That's why I have an f of x or r of x equals over here, okay? So that means I need to get y by itself, correct? So do you want to multiply by a 4 first? I'd probably just multiply by a 4 first. 4y minus 24 is equal to negative 1 times x plus 2. So that's a negative x minus 2. And then I could add 24 to both sides. So if I add a 24, I'm going to get negative x plus 22. And then I'm going to divide by 4. Negative 1/4 x plus 11 over 2 if I reduce it. Does that look right? Yep. Okay, is everybody okay with that? Give you a second to write that down if you need to. All right, so this quadratic function, if you look back at the front page, which format is it given to you in? Is this standard form? Is this vertex form, or is this some other form altogether? Okay, how do you know it's vertex form? Set up the same, right? I've got the parentheses squared. What number could I put on the end there? I can put a plus 0, right? So remember that vertex form looks like this, right? So your h and your k are your vertex. So what's my vertex?
It is negative 6, just regular 6, 0.
It is at 6, comma 0. Okay, does that make sense?
Yes.
Okay. Can you tell me if this is a happy face or a sad face?
It's a sad face.
It is a sad face because of that negative sign right there. It has an x-axis reflection. Okay, so this, if you look at the parent function, it's not going to shift up or down. It's going to shift right 6 and flip upside down. So this is an easy one to graph. Now, when you're doing this online, they're probably not going to ask you to graph it before they ask for all of these things. So it might be helpful to have graph paper on the side graphing these as you answer these questions. Okay? So that way you can graph them in order to answer those questions. So where's my vertex at? 6, 0, 2, 3, 4, 5, 6. So here's my vertex right there. This is a sad face parabola, and there's no compression or stretch. So what's the pattern that I use to graph the next points?
2,
Up 1 or down 1 over 1 because it's a sad face. And then you can also go over 2 and down 4 because 2 squared is 4, right? You can also go over 3 and down 9 if you want to make more points. So my parabola looks something like this. It's not very pretty, but there it is with my 5 special points. Okay, can you guys all see that okay?
Yeah.
Okay, so once again, if you were doing this online, they probably would not have you graph it first. So when they say how many x-intercepts exist, it might be helpful to graph that on graph paper so you can see that if you're a visual thinker. All right, so how many x-intercepts do I have? 1. And that x-intercept is, in fact, the same as so I only have 1. So I'm going to mark this blank out. And I have an x-intercept at 6, 0, same as the vertex, okay? Now, a y-intercept may be difficult to see on this one, right? I'm going to have to really draw a long way down to see the y-intercept. So what's the algebraic way to find a y-intercept?
Plug in.
Hey, let x be a 0. So if I want to know a y-intercept, I simply need to let the x be a 0. Let x equal 0, which is what I've done here. Replace the x with a 0. What is 0 minus 6? So right now I have a negative sign out front, and then I have a negative sign squared. That means I have 3 negative signs altogether, so my answer is going to come out negative. Right? Negative 6 times negative 6 is positive 36. Put that extra negative, so the y-intercept is at 0, comma, negative 36. Glad I didn't try to graph it. It's clear down there at 0, negative 36. See if that makes sense to you. Copenhagen, is that okay?
How is it still negative again?
Because I have, here's the mistake people make all the time. They look at this and go, oh, 2 negatives, it's positive, right? That's what everybody thinks.
You have to use the exponent first?
Yeah, exponents come first. So this is really a negative sign, then a negative 6, then a negative 6. That's what it really is, right? Okay, so write that on there if you need to. Okay, so now I have to give 2 other points. Well, if you've graphed it on graph paper, that's easy to do. You can just go name these 2 right here, right? Let's see, what would that be? My vertex was at 6, so that's 5, negative 1, 5, negative 1, and 7, negative 1. Both sides of the vertex. Those are the 2 points I always try and give, or the 2 that are around the vertex, providing they're not already an intercept or something. Everybody okay with that? Okay, everybody okay with our first quadratic function? Okay? Okay, let's go to the next one. Okay, what format do I have here? Vertex form or standard form? Oh, I got another vertex form. I love vertex form because it's so easy to see the vertex, right? It's called vertex form because it's super easy to see the vertex. What's my vertex?
4, negative 5.
Okay, has everybody got that? Change this number, keep this one the same, 4, negative 5. That's your vertex. So 4, negative 5. So now, once again, they're not going to have this graph ready for you yet, so you're going to graph it on graph paper. 4, negative 5. Is it a happy face or a sad face?
Happy face.
It is a happy face, so to find my other 2 points, I would go up 1 over 1, over 2, and up 4 means I have points there. And if you want to go over 3 and up 9 to get more, you most definitely can. So graph your thing. There we go. I'll put my original 5 points in green. Okay, now it asks us for x-intercepts. Can we find these x-intercepts by looking at the graph?
Yes.
We can? What do you think they'd be?
Oh, hold up. Don't.
They're fractions, right?
Yeah.
Or decimals. So it's going to be difficult to tell exactly where they're crossing the x-axis. We can make an estimate, but we probably can't get an exact answer. So I'm going to need to do these x-intercepts algebraically. Okay? How many x-intercepts are there?
2.
We can tell that, right? So once you tell the computer there's 2, they're going to pop up 2 boxes for you to put your intercepts in. So anytime I want to know an x-intercept, I need to replace what?
Y with 0.
Y with 0. So x-intercepts, let y equals 0. So if I let y equal 0, I'm going to have something that looks like this.
Nice.
Okay, so how do I solve one of those? I did that in chapter 2.
You gotta get x by itself.
How can I do that? Add 5 to both sides. So if I add 5 to both sides, I'm going to end up with 5 equals parentheses x minus 4 quantity squared.
Now
Square root both sides, yes. Okay, I wouldn't square the first, square the last, multiply and double. That'd be the hard way to do it. Not wrong, but hard, okay? So I'm going to square root both sides. I will rewrite it to be thorough for the sake of your notes. So I'm going to square root both sides. And let me shrink this down a little bit. I don't want to shrink that much.
you put a plus or minus.
Anytime you incorporate the square root, it's going to move my graph. Oh, no, it's not. If you're the one to put the square root in the problem, then yes, you should put a plus or minus. Okay? So I've got the plus or minus the square root of 5 equals x minus 4. The square and the square root cancel out. How do I get the x by itself?
You add 4.
Okay, take this minus 4, add a 4 to both sides. I end up with x being a 4 plus or minus the square root of 5. Okay? Aren't you glad you didn't try and guess that one? Now, I don't know what 4 plus the square root of 5 and 4 minus the square root of 5 are, but that would give me the decimals if I needed the decimals. I think they're going to ask you for exact, and so if you're going to do exact, you're going to write 4 plus the square root of 5, comma 0, and 4 minus the square root of 5, comma 0. Okay, if they wanted decimals rounded to 2 places, you'd have to type that in the calculator and give it. Okay, does that make sense? Everybody with me on how to find x-intercepts? We let y be 0, and then we solve the quadratic just like we did in chapter 2. See why it's important not to slack off? Because if you slacked off on these in chapter 2, now it's coming back to bite you, right? All right, now, y-intercept. How do I find a y-intercept?
Plug in x for 0.
Plug in, let x be a 0. So y-intercept,
Yep.
let x equal 0. So if I let my x be a 0, I'm going to have y equals 0 minus 4, quantity squared, minus 5. Okay, well, let's see. 0 minus 4 is negative 4. Negative 4 times negative 4 is 16. And 16 minus 5 gives me 11. So my y-intercept is 0, comma 11. And always make sure it makes sense. Do you think my graph would really go through 0, 11?
Yep.
Yeah, I think that's doable. I mean, obviously, if you got 0, negative 11, that wouldn't make sense with your picture, right? Okay, so think logically. Now I need 2 more points. Well, that's no problem. I can just go to my graph to get the other 2 points. How about these 2 right here? They would be easy to get. What's that point right there? Is that 2, negative 1?
Yes.
Okay, 2, negative 1. And 6, negative 1? Is that when it's 6? Yeah, I think so. Okay, is everybody okay with that example? All right. My next quadratic. All right, I got another one in vertex form. So cool. Why is vertex form so awesome? Because you can see the vertex when you're in vertex form, right? So what would my vertex be?
Negative 4, negative 2.
Opposite of this one, keep this one the same. So negative 4, negative 2. It does not matter that you have a negative out front. Okay, that would not change anything on your vertex. Okay, so let's, it says how many x-intercepts would I have? Well, let's get a graph of this to see. Negative 4, negative 2. Negative 4, negative 2 is right here. Is it a sad face or a happy face? So I go down 1 over 1 to make my sad face, or over 2 and down 4. And there's my parabola. Labeling my 5 base points with the green dots. Okay, and so now, does this thing cross the x-axis at all? No. So how many x-intercepts do I have? 0. So I don't need these two blanks.
Like an absent, but.
It may be. I'm not sure on that. I think it'll just say z. If you pick 0, 1, or 2, if you pick 0, nothing's going to pop up. Okay, y-intercept. Think about where your y-intercepts should. You should get a negative y-intercept, right? So if you're working it out and you get a positive, you know you did something wrong. How do I find a y-intercept?
Plug in X for 0.
Plug in x for 0, and that just did away with my ink, probably.
Maybe say another one you said.
What? Did you just say plug in X for 0?
They're making you cry because
Hang on just a second. Okay, so we said the vertex was at -4, -2. 1, 2, 3, 4, -2. Down 1 over 1.
what happened?
My ink disappeared. Okay, my fault. But okay, so I don't have any x-intercepts. To find a y-intercept, I let x equal 0, right?
Yeah.
So I've got y equals a negative sign, a 0, a +4, a squared, and a -2. So let's see, that would be a negative sign, a parentheses. What's 0 plus 4? 4. So now I have that. So remember, that means a 4 times a 4 with one negative sign in front. So that's going to be a -16 minus 2, which is
Negative.
-18.
Very nice.
So my y-intercept happens at 0, -18. Does that make sense?
Yep.
Okay, now I have to list 2 more points. I can look at my graph to find those 2 extra points. So right here, the vertex was here, so I'm going to try and do the points on both sides. So that's what, -5, comma, -3?
Yeah. Then -3,
Okay.
-3.
-5, -3, and -3, -3. Everybody okay with how we got those 2 points? Now remember, you can always pick numbers for x and work this out also. But if you have your graph, and I'll give you guys some graph paper to help you out with this. So I would always look there for the points. Everybody okay with that?
Yeah.
Okay. Example 8. Okay, is this one in vertex form, standard form, or neither?
Neither.
Yeah, that's not vertex or standard form. So what am I going to do?
You gotta do it.
Got to work it out and make it look like one of those two, right? Okay, well, let's do that. Let's take this thing right here and let's multiply that out. So that's going to be a y is equal to x squared. Then I would have a plus 5x and a minus 1x, which gives me 4x. And then -1 times 5 is -5. And then I have a plus 9 on the end. So I got these 3 terms from multiplying out my 2 parentheses. Is everybody okay with that?
Go.
Okay, so what's -5 plus 9? 4. So x squared plus 4x plus 4. Okay? What form am I in now?
You were the standard.
Oh. Well, what can I do when I'm in standard form?
You can.
How do I find a vertex when I'm in standard form? H
Oh, yeah.
is the x value of the vertex,
So you got the negative B over 2.
and that can be found by doing -b over 2a. Okay, well, what's the opposite of my b value? Okay, the opposite of my b value would be a -4. Over 2 times the a value, what's my a value? Coefficient of the squared would be a 1. So that's equal to -4 divided by 2, which is -2. So what does that -2 stand for?
Your X.
What did I just find? It's the x value of the vertex, my h, so that's a, did we say -2 or +2? Okay. Well, how am I going to find the y value of the vertex?
Plug that in.
Oh, plug it back in? Okay. So if I plug it back in, what am I going to get? So plug it back into the original function for x. X is a -2 Okay, so that's going to give me what? 4
Oh, hold on.
minus, positive 4 minus 8 plus 4.
You're gonna get 0.
I'm going to get 0. So my vertex is at negative 2 comma 0. Okay, so that means my vertex is right here. Happy face or sad face? How do you know?
There's no negative.
There's no negative on the x squared when I'm in standard form, so it's got to be a happy face. Is there any compression or stretch number on my x squared? Nope, so I can just use the basic up over 1 up 1, over 2 up 4. And if I graph it, guess what I just figured out? My x-intercepts and my y-intercepts are pretty easy just by looking at the graph, right? How many x-intercepts exist? 1. It happens to be right on the axis. It is the same as the vertex. I should be able to find my y-intercept just by looking here. What's that, up 4? 1, 2, 3, 4. So my y-intercept is at 0, 4. And 2 other points. Well, I could use these 2 right here, right? So negative 1, 1, and negative 3, 1.
Very nice.
Is everybody good with that? Okay, and next one. And I think this is the last one, right?
Yes.
So we got 5 minutes to do it. Okay, what format are we in? We got a happy face parabola with no compression or stretch in standard form. How do I find a vertex when I'm in standard form, guys?
You gotta put negative b over 2a.
Okay, the x value of the vertex we usually refer to as h, and h is the opposite of b over 2 times a. So what is the opposite of b?
9.
Negative 9 over 2 times 1 means I have a negative 9 halves for the x value in my vertex. Okay, now to find k, I need to go back and replace x with a negative 9 halves. So y or k is equal to y, and the y value of the vertex. So I have a negative 9 halves squared plus 9 times negative 9 halves plus 8. Is everybody with me on that one? Okay. All right. So at this point, I would not go straight to my calculator. It looks yucky, but you're going to make an error typing in this in the calculator if you try and type it in here because of all the negative signs, the squareds. You guys know what 9 times 9 and 2 times 2 are, right? 9 times 9 is 81, 2 times 2 is 4, a negative times a negative is a positive, so that comes out 81 over 4, positive. This one, you have to take 9 times 9 and 1 times 2, and you have one negative sign, so it's a negative 81 over 2. And then on the end, I have a plus 8. Now, go to your calculator and type it in. Get out your graphing calculator app, type in 81 divided by 4 minus 81 divided by 2 plus 8. And you'll want to have your graphing calculator in a mode that does improper fractions, not mixed numbers. Okay, so if you go to your mode button, you'll want the one that says, I think it says U over D, instead of, you don't want that. You just want a number. You want your fractions to look like that. So if you go down about halfway down where it says fraction, or partially there, 3 or 4 down, and pick U over D. So type that in and give me the improper fraction for it. I guess I can work it out by hand as you guys are doing it like that. Anybody got it yet? Surely you can type it in faster than I can work it.
It says negative 12.25.
Okay, so change it to a
Negative 49 over 4.
49 over 4, okay. And what was my x? A negative 9 halves? So clearly that one's not going to be a fun one to graph, right? Okay, now, under your mode button, if you go to fraction, you should be able to change that. Or even on the top one, where it says decimal,
Oh,
You know what I
okay,
mean?
was gonna say, if you change the
There's
way-
two things you can change.
Whenever you just do the UN over D or whatever, it didn't change anything.
Okay, so you gotta let it know you don't want a decimal. Okay, so we are in quadrant 3 with a happy face parabola. How many x-intercepts am I going to have?
Two.
If you're in quadrant 3 with a happy face, it's got to cross twice. Okay, so now to find those, see if we can do this real quick. How do you find x-intercepts?
You,
Let y be a 0. If I let y be a 0, I'm going to have this. 0 equals x squared plus 9x plus 8. How do I solve that? By factoring. Multiplies to give me 8 and adds to give me 9 would be 8 and 1. So my x-intercepts are at -8 and -1. Okay? So x-intercepts are at -8 and -1. Okay, and we're going to run out of time to finish this, but this part right here, to find a y-intercept, you just let x be 0 to find two other points. You're going to let x be a number and plug it in. Just let x be a 1, let x be a -1, and plug them in. Okay? All right, so you're ready to practice and certify on that one.